Bodenradar aus der Luft, ist zusammen mit unserem Partner der Firma SPA Engineering. Ich werde begleitet von dem Ralf Senkosens, und wir bringen Ihnen heute das Thema Bodenradar aus der Luft näher. Zum Ablauf ganz kurz. Ich gebe eine Übersicht über Kopters, wer wir sind, was wir machen. Und Ralf präsentiert dann das Bodenradarsystem und die Lösung im Detail. Der Teil wird dann auf Englisch sein. Ich hoffe, das ist für Sie in Ordnung. Wenn es da Schwierigkeiten gibt, auch kein Problem. Dann erklären wir bestimmte Punkte nochmal separat für Sie und freuen uns dann da auf weitere Gespräche. Aber kurz zu Kopters. Kopters ist eine Firma, die gibt es seit etwas über 8 Jahren. Wir kommen aus Großbritannien und wir vertreiben komplette Drohnenlösungen. Wir vertreiben Drohnen, die Hardware, Software. Wir machen das ganze Pilotentraining, Reparatur und Wartung. Und wir sind jetzt seit September letzten Jahres auch in Deutschland verfügbar. Wir vertreiben nicht nur das DJI-Portfolio, sondern auch andere Marken und gerade auch Sensoren von Herstellern, um unseren Kunden die bestmögliche Lösung für seine Anwendungsfälle zu geben. Grundsätzlich den Einsatz von Drohnen, der bringt eigentlich immer mit sich eine Kosteneffizienz, ein erhöhtes Maß an Sicherheit, naja, eine verbesserte Art und Weise und Geschwindigkeit, wie man Daten sammeln kann und dann die Möglichkeit hat, diese Daten zu präsentieren, aufzuarbeiten und innerhalb seines Teams und mit anderen zu teilen, um ja bestmögliche und effizientere Ergebnisse zu erreichen. Kopters selber, unser Produktportfolio umschließt Drohnen, verschiedene Arten von Drohnen, die Sensorik, die Nutzlasten, die auf der Drohne montiert werden, seien es hochauflösende Kameras, LiDAR-Scanner, Multispektralsensoren, Thermalsensoren, aber auch spezialisierte Sensoren von unserem Partner SP Engineering, wie Bodenradar, Magnetometer, Echolote, Methandetektoren auf der Drohne. Wir runden das Ganze ab mit Software, mit dem Training in den Produkten, so dass unsere Kunden das alles selbst bedienen können und sind hier dann eben der One-Stop-Shop für Drohnen und Sensorik. Wenn man jetzt Drohnen betrachtet, dann gibt es so die industrielle Einstiegsdrohne, das ist die Mavic 3 Enterprise oder Matrice 4. Da kriegt man Punktwolken raus, Meshes, Orthomosaik und digitale Bodenmodelle. Aber wenn man etwas Komplexeres benötigt und höhere Anforderungen hat, dann nutzt man eine Matrice 350 Drohne von DJI und hier kann man die Nutzlast flexibel austauschen. Und das Austauschen der Nutzlast bringt mit sich, dass man jetzt sehr viel Flexibilität hat für verschiedene Anwendungsfälle. Wir können auf der einen Seite hochauflösende Kameras nutzen, die uns helfen, noch bessere Fotogrammetriemodelle zu erstellen oder visuelle Inspektionen zu machen. Wir können LiDAR-Scanner benutzen, um Punktwolken zu generieren, digitale Bodenmodelle, und ja, wirklich leicht und schnell Vermessungsarbeiten machen zu können. Wir können Multispektralsensoren nutzen, um unsere Pflanzengesundheit zu überwachen oder Thermalsensoren für Rehkitzrettung, für Inspektionsarbeiten und andere Applikationen. Andere Anwendungen, hier geht es noch weiter mit den integrierten Nutzlasten von SPA Engineering, bietet sich jetzt auch die Möglichkeit, ein Magnetometer, ein Bodenradar, ein Echolot, Methandetektoren oder auch Gamma-Ray-Spektrometer auf die Drohne zu bringen. Und das bringt uns jetzt hier zu unserem Partner, der Firma SPA Engineering. Wir fokussieren uns nämlich heute jetzt in dieser Präsentation auf das Bodenradar und ich übergebe an meinen Kollegen Ralfs, der uns jetzt durchführt durch die Bodenradarlösung von SPA Engineering auf der Drohne.
Perfect. Thank you very much, Søren. Yeah, as mentioned in the beginning, I will do my part in English. I hope that is okay with you. If anybody has any trouble or issues, then of course Søren is always there to assist as well. So my name is Ralf Henkusens. I'm the Business Development Manager for Europe here at SPH Engineering. And what we do at SPH is we provide various drone-based integrated solutions for airborne geophysics. That would be the overarching theme of what we do. This includes, as Søren already mentioned, things like magnetometers on drones, echo sounders, and others. But the main topic of this webinar, obviously, is airborne ground-penetrating radars. Søren, if you can move along, please. Yeah. So As mentioned, so we provide various kinds of systems, and all of these systems have one unifying factor across all of them, and this is a technology that we call SkyHub. So what SkyHub is it's an onboard computer for all systems that allows you to do two main things. So first of all, it acts as a data logger, a data recording device, which records and more importantly, geotags all of the sensor data that is coming from the sensor. Because if we think about standard applications of using geophysical equipment, there usually is some kind of a data recording device that you need to use, whether that's a field laptop, a tablet, or something else. In this case, this is a small onboard computer that we attach to the drone on the system. And the second thing that it does is it ensures what we call true terrain following. This is essentially allows you to perform very low altitude flights as low as zero point 0.5 meters above the ground, which is crucially important for all geophysical applications, since you need to keep any sensor very close to the ground for maximum performance and for qualitative data. I would say, especially in the case of a ground penetrating radar. Um, yeah, we can proceed. So in general, most of our systems are used in various kinds of application fields, including construction, engineering, environmental studies, mineral exploration, and others. And what we allow our customers to do is to open up their possibilities of performing surveys where they otherwise would not be able to do so. So most of the equipment that we provide, most of them have a what I would call a traditional way of doing the survey. So if we think about ground penetrating radars, you typically do it on a cart or a trolley, just pushing it around survey lines and collecting data. For a magnetometer, again, whether this is a handheld magnetometer or whether you use it on an airplane, a helicopter, or a car, as well as with an echo sounder, again, you have a standard approach of doing this with a boat. But obviously, all of those typical standard applications have their limitations, whether this is the inability to access hard to reach areas or cover large areas. And what we do is we help to elevate both figuratively and literally elevate your surveys to be able to do this in areas where you otherwise would not be able to do it. Increasing your survey speed, data precision, ability to do this without the involvement of personnel, so increasing safety and other critical aspects of the survey. Next slide, please. So, I'm not sure how familiar each and every one of you is with a ground penetrating radar, but let me give you a very, very high level overview of how it works. Essentially, a ground penetrating radar or a GPR is a non-intrusive device for detecting items or anomalies in the near subsurface. It works through let's say, pulses of electromagnetic waves. So it has a transmitter and a receiver. So it transmits an electromagnetic wave into the ground, waits for reflections, and for the wave to be reflected back to the receiver. And this way you can, let's say, image the near subsurface for what we typically call anomalies. And these anomalies mostly depend on your survey. If you are looking, for example, for underground utilities, you will see something similar to what you see on the screen right now. So sort of hyperbolas of a certain item or an anomaly in the near subsurface. If the application is something different, for example, stratigraphy or earth layer profiling, you will see slightly different data visualizations in terms of where the medium changes, right? Once we hit a different soil type or different medium, part of the electromagnetic wave is reflected back to the GPR, this way showing you certain changes in the electromagnetic wave reflections in the near subsurface. So this is a non-intrusive way of detecting items. So instead of excavating to detect certain things underground, you use a GPR to do the same, but without disturbing the environment. Next slide, please. As I mentioned, in most cases, typically a GPR can be used for a number of different applications. The overarching theme, again, is to detect items or anomalies in the subsurface, which can mean quite a few different things. In our experience, the main fields of application typically are things like construction and engineering to understand and map, for example, utilities underground before construction work, during construction work, or at the end when you need to deliver the construction project. Things like near surface stratigraphy, so measuring earth layers, earth layer profiling, detection of cavities, tunnels, voids. So any sort of, let's call them uh, dangerous obstacles below the surface, as well as in the mining or mineral exploration industries. Again, looking for covering layers, as well as, again, looking for the same cavities or other types of voids. Uh, and another typical application scenario, very prominent within our customers, is from the field of research and education. A ground penetrating radar can very successfully be used for things like ice and snow studies, glaciology, and landslide prevention and landslide monitoring. This way, quite often our systems are used by various research centers, educational institutions for doing various research within glaciers, alpine environments, etc., to monitor constant changes in the environment there. But essentially, a GPR is quite a flexible tool. So if there is a requirement to image or detect certain things in the near subsurface, a GPR could potentially be the right solution here. Next slide, please. So as I mentioned, there are certain survey methods or how GPRs can be used in a standard application. This is by no means a new technology. GPR has been around for decades. And often it is used, as I mentioned, on a cart or a trolley, as you can see on the top left-hand corner. Um, this is a standard way of using a GPR, typically in construction and engineering. Probably many of you either have used this or have seen this used on construction sites where just, surveyors are walking survey lines. Similarly, you can do this in a handheld variant, either by dragging the GPR, with your hand or behind the vehicle, or picking up the GPR and walking along with it. All of these are great survey methods, standard survey methods, but of course, all of them come with certain limitations. If it is a very large area that you need to survey, or if the terrain is inaccessible, it's a very rough terrain, for example, or just simply it's dangerous and poses risks to the safety of the surveyors. This is where airborne GPRs can be very beneficial and can be sort of that additional layer of data acquisition that you can achieve. And one thing I wanted to mention was that all of those images that you see here, all of these can actually be performed with our GPRs. So our GPR systems, while we focus mainly on airborne applications, all of our GPR units can also be used in a terrestrial mode, basically. What this means is that you can have the same GPR unit, and this allows you maximum flexibility in terms of how you can actually use the system. Having the flexibility of doing both a terrestrial survey and an airborne survey opens up the doors for more applications and the ability to perform surveys in various kinds of areas. Doing a standard survey where the terrain allows, and once you arrive at an area where this is no longer possible, you simply take out the GPR, mount it onto a drone, which takes about 2 minutes, and then you can take flight and continue the survey that way. Next slide, please. Uh, in terms of the types of GPRs that we offer, there are three different models with different technical capabilities, each usually intended for slightly different applications. Um, the rule of thumb usually is that the higher the center frequency of the GPR, the less that you can penetrate the Earth in terms of depth, but you have higher resolution of the actual data. So what this means practically is that, for example, the Zond Aero 1000, which is a 1000 megahertz center frequency GPR, will achieve less depth penetration, but you will be able to detect smaller items because the resolution of the data is higher. Whereas, for example, the Zond Aero LF, which stands for low frequency, will allow you to achieve deeper depth penetration, up to 20 meters, 30 meters, or even more in certain conditions. But obviously, you will not be able to detect small items. So the Zond Aero LF, as an example, is typically used for things like stratigraphy or looking for or detecting, let's say, Earth layer profiles, where there is not a very small item that you are trying to detect, but rather the general change in the soil type or the medium. And the Zond Aero 500 is usually the sort of middle of the road utilitarian GPR that we provide. This model usually achieves quite good depth penetration, up to about 4 meters in good conditions, while still allowing you to detect relatively small items like standard utility pipes and so on. So usually for most applications that involve things like utility detection and similar, we typically suggest the Zond Aero 500. I see a question coming in about the Zond Aero LF. So the Zond Aero LF by default comes with three interchangeable antenna dipoles with 100, 150, and 300 megahertz antennas. There are custom frequencies available as well, starting as low as 75 megahertz up to 400 megahertz. So it's essentially you can interchange the antenna dipoles, as you can see on the image. So there's the control unit in the middle, and there's an antenna dipole going through the GPR. So you can simply change the frequency that you would need. The 500 and the 1000, those are shielded antennas, and they are set in terms of the center frequency. Um, but the LF is you can interchange depending on the depth and resolution you want to achieve. Next slide, please. So I've already alluded to a couple of reasons why we focus on airborne GPRs or why we sort of develop these systems. And this is essentially to allow our customers and surveyors to achieve more with what they already have. In quite a lot of cases, we already work with customers who have vast experience with GPRs, who perhaps use GPRs on a cart or otherwise are familiar with the systems. So there, the main, let's say, doubt from their side is often that you know, as soon as you elevate a GPR off the ground, even slightly, you lose quite a lot of depth penetration. While that is true, you do lose some of the power of the electromagnetic wave. Still, in relatively good soil conditions, you can achieve really good results with an airborne GPR as well. Um, of course, for GPRs, usually the drier the soil, the better the depth penetration. So the soil has to be, let's say, relatively less saturated. The ideal conditions is dry soil, things like sandy soil, etc. If there's quite a lot of clay content, it could be difficult because obviously if it's quite saturated, then uh, a lot of the EM wave is let's say dissipates in the saturated soil. But you will see similar challenges also with the terrestrial GPR as well. So make sure that the soil conditions are favorable for GPR surveys. And also critical here is to keep the antenna as low or as close to the ground as possible. And this is, again, an advantage of our systems, right? You would not be able to fly just by attaching a GPR to the drone and flying a standard survey, right? You do require low altitude flights. And this is where our systems come into play and how they are helpful. Typically, for standard GPR applications, we usually suggest to plan the mission at an altitude of about 0.5 to 1 meter above the terrain, if the terrain allows for this. This way, you can achieve still relatively good depth penetration without losing too much of the EM wave power. And again, the main advantages of doing an airborne survey, as I mentioned, is being able to do this where you otherwise would not. So difficult terrains, inaccessible terrains, areas which pose, let's say, risks to health and safety of the personnel and surveyors, as well as this helps you to increase productivity. So if you think about a terrestrial GPR, which you simply push on a cart, you are limited by how fast you can move, right? Which is, what is it, 4 or 5 kilometers per hour is probably the average walking speed of a person. With the drone, you obviously do this a lot quicker. We usually suggest flight speeds of about 6, 7, up to 10 meters per second. This is sort of the ideal scenario, which already highly increases your survey speed. Typically, the survey line separation is at about 1 meter. This depends on the survey characteristics, but it's usually approximately 1 meter between survey lines. So again, with the drone, it allows you to perform those surveys quite efficiently. And also, all of our systems are well within the payload capacity of a standard DJI M350 drone. All of those systems are fully compatible. It's essentially a plug-and-play system. And also, the typical flight time that we see is around 25, 27, 28 minutes, depending on the weather conditions and flight characteristics. But this means that you can, perform those surveys, again, relatively efficiently. And then it's just a matter of changing the batteries and continuing the survey from where you left off. But of course, as is the final point on the slide here as well, we don't want, and this is never the case, that an airborne GPR is going to be the silver bullet or that it's going to replace standard terrestrial GPR surveys. That is absolutely not the case. In most cases, still a standard GPR survey is going to be much more efficient, just because if you can do it in that specific area, then this will give you more qualitative data, no doubt about that. But where an airborne GPR comes into play is where you otherwise would not be able to continue that survey, right? Or if the area is just that large. So instead of doing this survey for 3 days straight, you can just complete it in half a day by using a drone. Or if you can't collect data in a certain area otherwise, you are either losing a potential job or not being able to perform the survey, to this way achieving the possibility of completing the survey in its entirety by using an airborne solution. And again, keep in mind that our systems are flexible and universal, meaning that they can be used both on a drone as well as on a cart or as a handheld system. Next slide, please. So just wanted to give a little bit more of a practical overview of how our systems often are used and can be used. We have a couple of case studies available here, and much more are available on our website and our LinkedIn page. But just wanted to cover 2 standard applications of how our GPRs are often used. The first one is utilities detection. This is a case study that was performed by one of our partners over in the UAE, where they were able to successfully detect even plastic utility pipes at the depth of up to 0.7 meters. Why I say even plastic pipes? Because it's often the case that plastic pipes are not easy to detect because plastic is obviously a non-conductive material, and since this is electromagnetic waves that are on the principle of detection here, it's often challenging to detect plastic pipes, especially if they are empty plastic pipes. If there is water running through those pipes, then it's obviously a lot easier, but standard empty plastic pipes can sometimes be a challenge. But in this case, in this example, the customer was able to precisely detect the specific running of those plastic pipes. So they did 16 survey lines, each 50 meters long, with that 1 meter line spacing. Of course, since the survey was performed in the UAE, the soil conditions were very favorable, obviously dry sand. That's why that might be one of the reasons why they were able to successfully detect those plastic pipes. But in Europe, the standard scenario is that quite often also steel pipes are used for standard utilities. Yeah, usually the depth, in our experience, at which they are laid are somewhere between 1 and 2 meters. So well within the performance capacity of our standard Zond Aero 500. If you want to learn more, the QR code leads you to the specific case study, so feel free to take a look at this and others as well. Next, please. And the other case study is around our, let's say, research and education customers. In this case specifically, this is our customer, Geo Research from Austria. It's a non-profit organization who focuses on preserving glaciers and ensuring safety in the alpine regions here in Europe. They use our systems very successfully in various alpine conditions, either for snowpack monitoring or for glacier thickness measurements. This is just one example of the type of surveys that they have done. They use our equipment very often. They have both the Zond Aero 1000 as well as the low frequency option for various different applications. And since snow and ice is a very favorable medium for GPR, you can achieve a really good depth penetration, up to hundreds of meters in some cases, to measure and detect glacier thickness. And what they do is they essentially monitor the change in those glaciers to study and survey potential risks both to people as well as impact on the environment. So again, the QR code leads you to the case study on our website. There also is more information available there as well, because we also did a joint research paper on this topic as well. Next slide, please. So this would be on a very high level it. What I wanted to mention at the very end is that how we typically engage with customers is that we provide them with a full system, both in terms of the hardware and software elements, as well as a full training course on how to use that equipment. Because there are certain differences between if you have experience using a GPR on a cart, there will be differences of how you use it on a drone, of course. So we want to make sure that you are fully aware of the best practices and how to use this. So we provide all of our customers with a full training course on using the system, but also a full training course on processing the data and interpreting the data. Because this is in most cases where the magic happens. As you saw in those couple of examples, the data usually looks like, GPR slices, black and white lines, etc. So without experience, it can be challenging to interpret the data and understand what you're looking at. So our geophysicists, geologists help you to make sense of the data processing steps and data interpretation. So at the end of the process, you can be successful in using that equipment, successfully. So I think that's all the time we have. And from my side, I think, sorry, if there's anything you want to say to wrap up, then please do.
Ja, noch ganz kurz zum Ende. Vielen Dank, dass Sie dabei waren. So als nächsten Schritt, was es für Möglichkeiten gibt, mehr zu lernen, ist das natürlich einmal zu sehen und auszuprobieren. Wir würden uns freuen, wenn Sie mit uns ein Meeting vereinbaren, um die Lösung im noch größeren Detail kennenzulernen und und Fragen zu klären. Darüber hinaus gibt es die Möglichkeit, dass die Firma SPR Engineering und wir zu Ihnen kommen, die Produkte vorführen und vor Ort zeigen. Das ist allerdings immer mit Kosten verbunden. Aber es gibt auch die Möglichkeit, dass Sie nach Riga kommen, ins Headquarter von SPR Engineering. Da gibt es ein Testfeld und ausgiebig Zeit, um die Lösung zu besprechen, zu zeigen und ja, sich genauer damit zu befassen. Ja, verbinden Sie sich mit uns, lassen Sie uns Ihre Fragen zukommen. Und ja, das ist das Ende von dem Webinar heute. Vielen Dank, dass Sie dabei waren. Und wir würden jetzt das Ganze hier für Fragen öffnen. Wir sind schon ein bisschen drüber über die Zeit. Also wenn Sie jetzt arbeiten müssen, dann gehen Sie arbeiten. Aber wir sind auch noch hier für ein paar Minuten, um Ihre Fragen zu beantworten und freuen uns dann auf weitere Gespräche mit Ihnen.